Thanks everyone for joining for day two of the V2 dig in Kent. Thanks everyone who joined in last night. It was a great discussion. That talk has gone up on YouTube, so it should be available for everyone to check out if they haven't already done so. For those who don't know me, I'm Daniel Lay. I'm a PhD candidate at the University of New England. One thing I forgot to mention last night was we've got a number of UNE Archaeology Society members acting as moderators in this group. That includes the current president, which is May Zarb, as well as James Roberts and James Kitely. So thank you to everyone who's working behind the scenes on these videos. Now we've got Colin here connected already, so I'll hand it over to Colin to give a bit of a rundown of what's happened in the last 24 hours.
Daniel, thank you very much and welcome to the dig. I'm going to switch the camera around so you can see exactly what I'm looking at. Right, so we're going to head down to the crater site. We've got various protocols. In this one, obvious. I'm just going to introduce you to Alice Leader, who's preparing to go off to study archaeology at Durham. I'm very proud to be having her on board. Can you just go through there? Thanks. Right. Now, our crater became very difficult to trace in the section. And we had to make a decision about the way that we were going to proceed. The trajectory of the V2 was from this direction across towards where the blue bucket is, the blue fines tray. What we decided was that since we had the surveying team on board with some very high-powered equipment, that we were going to dig around the crater walls. Now, some of you may remember that the problem with the V2 rocket that we have come across before is that it actually has a characteristic of melting the soil. And we think it's true for clay. By melting, I don't mean heat melting particularly, it's the shock wave that seems to reduce the clay to a liquid form. So it means there have been finds in that back wall, but you cannot see them having travelled into the wall. I'm just going to take you down in the crater. I hope the reception stays. So at present, we are just about 8 feet down, and I've been thinking about Christine DeVeth because we have found that we've got a bed of ragstone. That's a marker that I've playing team. So the ragstone is higher on this side of the crater. It seems to travel down, and we've met it again over here. So in terms of height, I guess we're about 12 inches lower this side. In the middle of the crater, unsurprisingly, there's no ragstone at the moment. We don't know if it's been depressed or if it's no longer in existence, but as we travel up back towards the incoming trajectory, we've got finds in the section. Typically, this that I expect you've come across before. That's aluminium alloy that has degraded considerably, and at the moment is that normally in clay it preserves the fines very well, but everything that we found so is a shocking state. So somehow we think water and air is getting into the crater, and we've got a feeling it's something to do with the ragstone, but I guess Christine's going to have a point of view about that. Right, so we're going to come out of the crater. Do you remember yesterday in that back wall at the bottom there was a find? So we've got a find on the back wall opposite the direction it was fired from. There was a similar find up here near where the excavator is working. The plan is to start to scrape back. I mean, basically, you've got to appreciate that this thing is our trowel, because there is absolutely no way that you could hand trowel that stuff over there. It's rock hard, really firm clay. We're going to trowel back towards this slope here, and we're noticing that we're getting more and more finds coming this way. So up to the finds. We've taken one tray back so far. Here's a classic find. This here is a burner cup. My brother Sean is going to talk to you in a moment about the function of the burner cup in the combustion chamber. This is the skirt of the bottom of the combustion chamber, and when conserved, just try and get a good position for you, across here, that is one of the wrinkles that you see around the combustion chamber. Inside that, there will be a feed, a series of holes that the alcohol sprays into the combustion chamber. And Rod is going to tell you about that. It's called cooling. If I was able to look right inside, let's get the camera right. Where are we? There we are. Looking right inside this, there'd be a series of honeycomb shapes. So, combustion chamber, burner cup, part of the combustion chamber. This is the central spline. It's not a great example, but it's part of the central spline from the spline shaft from the turbo pump. I guess you can see some of the spline gear markings on that. Not great bits of shrapnel from the fuel tanks. In here we've got more of the skirting from the combustion chamber. So the 2 points that I showed you a moment ago, that came from near the excavator in section. That came from the bottom of the crater in section. So this one was much lower than this one. And we believe that the central point between the two, we're beginning to wonder if the whole thing detonated at that point and went out radially around the impact. We were fully expecting to find all of our major finds down the bottom end of the crater there. Normally they travel along the trajectory and end up there. Sometimes there's an effect by the slope that you can see here. It normally slews it into the slope on the left, but we're finding absolutely no evidence of that at the moment. But we're on to that, we're working towards that. Before I hand over to Sean, I'm just going to nip over here to show Christine what's come out of the sections. So typical Kentish ragstone, this stuff, form of limestone, very hard. We think that stopped the rocket going down any further, which would have been slowing as it travelled through the earth. This was what I was talking about yesterday here. These pebbles, higher up in the section, we're finding those apparently sea or beach-worn pebbles and some flint, but no real evidence of major trauma to any of it. Surveying equipment, those of you who are great fans of this sort of thing, this is the equipment that's being used by our surveying team, JC White Geomatics. Completely brilliant. So the decision we had to make, take you to see this, yeah, you see that? The decision we had to make was we're going to dig out the entire crater shape because we couldn't see it anyway. But the machines, the digital surveying machines, are going to record in space where everything of a major value was discovered, including the ragstone level. So we're going to end up with a crater that we can examine over the period of the time that we conducted the excavation. And at the end of it, we'll be able to see the entire void that we created with, in space, all of the locations of the finds. So that is going to be completely wonderful to be able to unravel what actually happened with the physics of the impact. Right, I'm heading over to my brother, who I'm going to insist puts on these white gloves, because he's going to explain the function of the burner cup. And this is the burner cup that I've sectioned from another site in North Kent. Okay. All yours.
Morning. Right. So the burner cup acted rather like a carburetor does. So it mixes the fuel with oxygen. So the fuel being the alcohol. And it was brought together in a series of 18 combustion cups. So the principle of operation was at the top here was the oxygen feed. And that came down through into a brass rose with perforations. And you can see the brass rose, which fits into place just there. So that takes the oxygen down through. The alcohol took rather a circuitous route through the rocket. One of the problems that they had early on was burn through of the steel. And to prevent that happening, they developed a double skin combustion chamber. And so the alcohol first went down to the bottom of the combustion chamber, in between the two skins, and there were a series of small holes in rings around the inside of the combustion chamber, which the alcohol leaked out of, and that gave a film cooling effect. And it also heated up the alcohol so that it was in a better position to be burnt in the combustion cup. All of these little brass buttons are injector nozzles, and they all, you can see that there are differences in the manufacture. So some of them produced a swirl pattern, some of them an atomized pattern, and some of them were just direct injection. And they even had, I think there's about 6 different variations of these little, even played with alternate injectors of different types to try and get the maximum combustion. And you can also see that there's a small series of holes here, which also injected the alcohol. So originally, when the rocket motor was being developed, they developed a motor which gave 1 ton of thrust. And unfortunately, the person that developed that was a chap called Rydell, and he was killed in an accident. They didn't have anybody who was skilled enough to actually produce a rocket motor with 25 tons of thrust. So what they did was they took the 1 ton motor and just scaled it up 18 times. And that's why we've got 18 of these things on the top end of the combustion chamber. We've got some interesting details which we've been following up on, but quite often we can find okay. The German.
Can you see that, Daniel? See the writing? Okay.
Okay. So initially, when we started seeing markings on the part, we thought that they'd actually been signed by a technician. But it turns out that the Germans developed a whole series of secret armament supplier codes. We've now got documentation where we can identify which armament supplier supplied these bits and pieces. And the fascinating thing is that there was a spider's web of suppliers right throughout Germany and the occupied territories. So you had people in Czechoslovakia making injectors. You had the factory at Peenemünde, where they were first testing the rockets, making bits and pieces. And if you read some of the documentation, it leads you to believe that the Germans manufactured everything inside the tunnels at Nordhausen. But in actual fact, those tunnels were just an assembly plant, and they were buying in all the bits and pieces right throughout the German territories and just assembling them at Peenemünde.
Okay. Right. Okay, I'm going to take you to meet Andy, who is just going to chat to us very briefly, please, about the equipment that you've got. Can I just come this side so we haven't got the sun anywhere?
Remove?
Probably just that way would be good.
Actually,
That's good.
I can point
Perfect.
to some instruments there.
Perfect, lovely.
Because we've basically got three primary bits of equipment that we're using. One, if you swivel around, that's GPS. So that positions everything that we do according to Ordnance Survey grid. This one here, that's a total station. That's the modern version of a theodolite. That then creates a localized grid for the site and gives us that whole control. And that's also been used to actually individual items of fire as they've been highlighted. And then the other piece of equipment we have just over there in front of the digger, that's our laser scanner, which is basically capturing a 3D point cloud of the entire site, which provides, I suppose, essentially the context, doesn't it, for the excavation and the finds and so forth, things like that. And what we do is we use all three instruments to create one, ultimately, one 3D capture of the entire project.
So, Andy, normally this isn't the type of surveying that you do, is it? You do like building surveying?
Mostly, most of our work is in connection with the construction industry, both from sort of surveying sites and buildings and structures prior to any work carried out. We also do some engineering work where we will set things out, like where a building is going or road or something like that. But we do some work in connection with archaeological sort of finds sometimes, but more by way of capturing records. We're doing some stuff for some archaeologists at the moment, which is recording building elements.
So in terms of the technology,
Yep.
is that moving ahead rapidly at the moment, or has there been a burst of that?
Yeah, because the technology is such a big part of what we do, and as it evolves and becomes much better, primarily what it's done is take a lot of the sort of long time manual calculation out of it in some regard, and what it enables us to do. So, for example, what with the total station, that one will record 1 point at a time. The laser scanner records, I think it's about 900,000 points per second.
It's incredible.
And that's how it creates, and because it's taken like a 3D swipe, that's how it creates that 3D environment. So that's where the kind of, improving technology allows us to gather more and better quality data and quicker.
And what about at the beginning of this project that we devised together, we talked a bit about photogrammetry. I guess everybody watching this probably knows about photogrammetry, but can you just give a description in case there's somebody who don't?
Well, essentially an extraordinarily old sort of technology, basically. But one of the things, I suppose, that modern computing, especially, and improvement of photographic equipment like digital photography, it means that it's what was previously done in a very manual way can now be done automatically, or automated through software. So where you might combine work through a collection of photos, we can work with a collection of hundreds of photos through software and create quite sophisticated outcomes. I mean, that's underlining the you know, what we do with our drone surveys, for example. That's all done through photography, and we will produce accurate aerial photographic maps and so forth and things like that. But you can actually model structures and things from the photogrammetry. But the IT, you know, a serious have their strengths, you know. So for example, we're doing something at the moment where we're capturing stained glass window, which for the laser scan is a little bit difficult because the glass will kind of splay some of the laser point cloud information. It can get a bit noisy, a bit messy, but obviously photographs are very clean. So for something like that, we're actually more inclined to use photogrammetry.
And the other thing that we spoke about was your particular interest from your side of this equation with the excavation was to learn the best way of communicating this information to clients.
Yeah, it is bit of a challenge, but say that.
I mean, we're talking about computers, aren't we?
Yeah,
how to deliver the product.
Yeah, I mean, it's a bit of a challenge, but it's very much, you know, we do that in a positive way, and it is across, you know, across the board, across the industry. Because one of the things with the laser scanning, especially, is like we're able to capture huge amounts of information, and it's a case of how best to use that. We've got this raw sort of material, and how best to kind of use that, and in a way that's useful for different clients and their different needs and so forth. And visually it's very powerful. But what quite often we're producing quite conventional drawings, orthographic two-dimensional drawings, typically from a day-to-day point of view. But what we see back in the office, what we're actually producing those drawings of, is visually more interesting because that's the 3D point cloud. So it is an ongoing thing from all sides, including software producers and all the rest of it, to actually try and make more use of the point cloud itself, especially for 3D visualizations and things like that. And for something like this, you know, you've got a 3D visual tool that you can work on and provides a bit of a timeline of your excavation, and that's really brilliant, you know. And it's just, I suppose, you know, a bit of interest for us is how to kind of try and achieve that.
Thank you very much.
No problem.
Andy, thank you. So to just put everything into a nice, neat box for you in terms of the actual excavation, I would say we've got one finds crate that's gone back to our office. And what I've just shown you are the major finds, but that's only about a 1/12 of what we'd expect for a V2 rocket site. So we're just expecting, and if you're following me on Twitter, you will know the answer to this, but we're expecting an awful lot of material to be coming out of the back end. So the physics, I think I showed you the trees yesterday. These are very tall oak trees. And it's about the standard height just there. We're thinking the impact fuse started to detonate as it was coming in, which meant that there was far more dispersal of the finds, whereas when it's actually hitting the ground and going in, the rocket tends to follow that impact. This type of impact, it's more or less the impact with the air above the ground has begun before it gets to the ground. So we're wondering if the heavy items, like, I mean, we're talking about 4 tons of rocket coming down. Typically we find 3/4 of a ton of rocket. And we've hardly found, I guess we're looking at something like 50 kilograms so far. So we're nowhere near it. We think that has got to be somewhere in the hole. And we are now beginning to realize that because of the type of impact this is, that it's at this end, not that end. But in order to check, we have had to excavate further than we knew the crater to exist to make sure that there's nothing back there, because the beauty of involving the surveying team is that we're going to be able to analyze this for months. Game changer for us. I wonder if there's anything else I can tell you about. Oh yes, there is. Yesterday I mentioned something about some insulation on the rocket. I'm just going to get this out. Don't look too untidy. So this came from the same site as the burner cup that let's get into the light so you can see that. Right, piece of fuel tank, heavily pierced by fragments, but when you turn it over, this only came about through my conservation work on it, which took basically a year. Now I'm looking at Daniel and I'm turning that. Can you tell me if you can see the mesh pattern on that? Can you see that? Tell me when to stop.
Think,
Can you see it yet?
yeah.
Mesh pattern. It's basically it's chicken wire.
Yeah, yeah.
So that has been caused by the impact. The chicken wire was holding insulation material, glass fiber, in between the fuel tank and the outer skin of the rocket. The impact has forced that pattern into the outer skin of the aluminium.
Can definitely see it now. So
Yes, it's completely crazy. I bought something else.
and I hope you're still there, Colin.
Said to me, Mr.
Yep.
Welch. Can you hear me?
Yep, now we've got you. Yep.
Yep, got me. Okay, did some work with the primary school, and a student said, Mr. Welch, do you know that the shock wave before a V2 rocket made the Earth go down about an inch? Well, that got me thinking about things, and my figures are not going to be accurate, so they're a ballpark. This is an exact cubic centimetre, where's the thing, of steel. And I think you'll find that weighs something like 7.9 grams. I might be mistaken there, forgive me if I'm wrong. But we worked out that it would take 7.6 billion of those to equate to the energy release at the time of impact of a V2 rocket. Because it's quite hard to actually imagine what's gone on a site like this. I think I may have used the word almost supernatural yesterday, certainly to somebody. It changed the ground completely. The artifacts that are coming out of the ground, they're not in great condition from this side, but some of them, you can see a terrible event has happened to them. The whole thing's been shredded. It's for us, a very interesting telling story that we're unraveling as we do. I'm going to get that laser scanner moving. As we're going through our excavations, our picture and understanding of crater size, finds depth, and what it all means in terms of the impact, the recorded details at the time, it's turning out to be a really amazing story. I'm going to ask you now if there are any questions, please.
Do we have any questions?
Can you hear me, Danny?
Yep, that we did. James, either Kitely or Roberts, did either of you have any questions?
I can see one from
there's one in
James
the
Kitely
chat.
in the chat. Yeah. Do you want to read it out, mate?
Yeah, I'll take it. So just a question we had discussion yesterday after we disconnected from you, Colin, was the aluminium you showed us yesterday from around the site. Was that in the finds box, was that sort of surface debris and normal, and how did you find it?
Right. The first thing that we do is archive work. Then it's desk-based research, for example, LiDAR. Then we get to the site and see if the LiDAR matches up with where we think it is. And when we get a match, we conduct a blast field search. So with metal detectors in the woodland all around, we go around and GPS each find. So in this case, let's just do this. In this case, if you've got your bearings of the site now, digger over there, the incoming trajectory, the blast field, all of those fragments of fuel tank ended up that side of the crater. Just turn it around again. So the GPS situation is really useful, but I've been alarmed this morning to learn from our surveying engineers here that they're paying an absolute fortune to have the GPS updated because of, how did you describe it, Andy? Moving data. There's a real-time correction. So for all of us archaeologists wandering around, relying on our handheld GPS units, it turns out that they're not entirely accurate. All we can say is that the pattern that we built shows a fan of material going in a certain direction, but I'm no longer confident that it's as accurate as I would like it to be.
Is that a variation of a couple of meters or bigger than that?
No, 20, 25 meters, 30 meters, I think at most. The finds themselves were shredded fuel tank, and the interesting thing is some parts of the turbo pump right in the heart of the missile. Any more questions, James?
I have a question about the finds that you showed us today.
Yes.
Just the condition that they're in. So obviously some level of that is obviously detonation, but you're talking about the fact that you think water and oxygen has gotten into the site. I'm assuming the comparative ones you had been cleaned up quite a bit.
Yes.
Yeah, just if you can kind of comment more on whether their current appearance is pretty standard or if that's because there's water on the site.
Well, I know that I'll be able to do some good conservation work on the finds, but the condition of it, with so much rust basically, is degraded the surface. I'll try to post things on Twitter so you can see what happens after the conservation work. But at the moment, the top surface of the steel itself is very friable. When I touch it or flake it, it's coming off too easily. And these are in fairly rough condition, I would say. The aluminium alloy is the same. It's oxidized. So that must mean that air is getting in somewhere. However, I have to tell you, the sectioned burner cup, that came from a chalk site. And let's do it properly because I don't want to get my fingers. And at the primary school, touched all of my finds. That's what happens after a while. Can you see that? Even though it's been properly conserved, the rust wants to come back. I can't see anything that I'm trying to describe to you. Usually on the top of this, on the top of that flange, there's lettering. The Marden excavation that we carried out was in heavy clay, and along this surface here, there were a series of letters. And as Sean was explaining, they're the manufacturer's code. So the condition from the chalk, where air was getting into the chalk, and I think nitrates from the field that it was in, was meaning that they're degrading quite fast. I'm not very happy with the state of the finds at the moment that are coming out of that hole.
Yeah. No, thank you. I did think that they looked a bit rusted. So.
Yeah. But,
just wondering
but we're not at the major impact site yet. There's somewhere in this area, there is a serious lump of it. And I would anticipate that because everything's more collected at that point, from what we found at other sites, I think we're going to get something that's better preserved.
Oh, fantastic. No, thank you.
Thank you. Any more questions?
Yeah, I had a quick one, Colin, if that's all right. First of all, thank you for this. This is fantastic. It's really good to be able to, be brought onto site like this. And you and your brother are doing a fantastic job both nights. It's been great to, see the site and get the lecture too. It's fantastic. So yeah, thank you. Dan sent through the research report that you sent through, just to a few of us, just to kind of get an idea of the wider aim here. And I like the fact that, what was that, sorry?
Is that the project design?
Yes, yeah, the project design, yeah.
Is that what? Yes, yeah.
And so, yeah, I like the fact that you're tying this into a wider, project. Your aim is not just this site, but it's all the sites you've looked at. And I was wondering if you could speak a little bit on how this site is going to fit into your wider kind of research narrative here, research outcome from all this work.
Well, the big situation, there are so many aspects to that. The big situation is comparing these sites, V2 weapon sites, to V1 sites, right, and trying to unravel historically what that means. And one of the things we have discovered is that the V1, the flying bomb,
yes,
the big that one was carrying 1 ton of explosive, but it had at least 2 point detonators. One was underneath, so as the flying bomb was coming in, if it was gliding down, it would go off. But if it was coming down at an angle, it would definitely go off, and it's at a slower speed. Right. So that's a really effective blast weapon in places like London. This, if it didn't strike a building, would just go straight into the ground at 3 times the speed of sound and detonate at least 5 feet under the ground. Wow. So what we are doing is collecting enough information to try to understand what that means in terms of excavation. We're learning more and more about the angles that the rockets were falling in. I mean, this has fallen considerably short of London, but yes, we have looked at rockets across the southeast of England on different trajectories and different soils. And we're finding that there are different patterns. Yesterday, I was explaining about the one that we don't think actually detonated, but the force of the impact alone at that speed created a bigger crater than somewhere like this has. The hole that we had to dig was at the other side that we don't think it detonated at. It was actually 28 feet deep, whereas we're about 10 feet down here. So there would have been colossal amounts of earth at that site. The list about what we're learning just goes on and on and on, because once you start to scratch the surface of how they were made, the fight against them, that leads you on to other areas of research. For example, in 2016, we excavated a Hawker Tempest at a place called Acres near Folkestone in Kent, where I've got to tell you, a licensed excavation where the pilot was on flying bomb patrol, and that opened up another avenue of research to find out about what happened there, why the airplane just fell out of the sky.
Yeah.
A flying bomb that we excavated recently near Ashford. We found the tailpipe, you can see this on Twitter, that showed strikes from the ammunition of 20mm cannon fire and half-inch strikes, which matches up to the National Archives combat report of the incident. So 2 aircraft achieved this thing. So it's really wonderful to have the history springing out of the ground, and to be able to interpret it. The primary school situation that I was involved with last year, apart from getting their fingerprints all over the conserved finds, I couldn't believe it, and it made it go all rusty. it was so valuable because they took it completely seriously and formed their own project around the excavation. So there's a whole generation of people there who know more about the V2 rockets than I do, I think.
Fantastic. Good on you, Colin. That's really good. Yeah, thank you very much for that.
Anybody else with questions?
I'll come in there and just to follow up, that was terrific. And I'd also like to back up the other James's. Thanks for this. It's fascinating, quite bizarre to be dialing in from the other side of the planet to watching you guys in the hole, but terrific stuff, really good. I just wanted to pick up a couple of points you were making there about netting back to the paperwork and other references and other resources. The stamps you mentioned actually on the metalwork on the ring there you showed us. Was that stuff a complete surprise, or did you know some of it already?
Complete surprise, because I think you've got to face it. Nationally, you in Australia, us here in England, you're only able to see a sort of fragment of the whole world. This that we're doing together now is really important. To be able to beam our ideas across the whole world and discuss is really important. So we were given to understand that we were sort of industry leaders in building, for example, the Spitfire aircraft that could be constructed in small workshops across the whole country. They were stamped with numbers. So came, James, you're still there? Okay. Along came these finds with a sans serif type, typically a capital letter and a small lowercase letter. We did some research, and there is a truly extraordinary book that has been published by a German author that analyzes the secret codes of the armaments of German weaponry. And sure enough, when we consulted that, we started to get what we were looking for. The Germans had a series of manufacturing industries in different places, dispersed so that if one got bombed, they could rely on another. It's just sort of common sense. But to us, that was major news that that was actually going on, because we'd never come across the information before. Okay.
Thank you very much. Yeah, great answer.
Okay, thanks.
And I think that's it based on the
Anybody
questions.
else with any questions?
No, I don't think that. I think that's it.
Right, well, I'm going to say the thank you to Daniel and your entire team there for making this possible. For us, this is the way to go. I hope to see some excavations by you online that I'll certainly be following, because the only way that we're going to get out of a sort of a country-centric idea about history is if we go across the world, around the world. I think it's very important. Forgive me for being so pompous to say that, but I think it's so valuable what you've put together here for us. Thank you very much.
Thank you for taking time out of your, what is it, 3 days to to share this.
These are the 2 major days. Tomorrow it's going to be a clean-up. So this afternoon, hoping to get the answers.
No, thank you.
Thank you very much.
No, thank you very much. Thank you, Colin, and thank you, Sean, and to everyone else that's actually been part of it. So
follow the Twitter. Are you there, Daniel?
Yeah.
Just one more point, Dan. Can you hear me still, Dan? Okay,
yep.
Follow the Twitter, then you'll know what's happening for the rest of the afternoon. Our V2 story is going to come out in a really excellent academic magazine called Iron Cross magazine. That's edited by a great personality in this field, Andy Saunders. A very special magazine because it goes into great depth about archaeological work in the field and other aspects of German military history. Okay, that's it, folks.
Thank you very much.
Yeah, thanks,
good luck for the rest of the afternoon.
Thanks.